So today's agenda is I will look at working with views and key preserved table. This was one topic that was ignored, I think, when we were going through joins. So we'll cover that. We will also focus on some of these topics on formatting output, working with DML statements, and transactions if we have time. We can also put transactions probably for next time around, like on the 28th, when I begin to get you ready for working with Lab 6. And then we can talk about your midterm. So we can spend a few minutes on Lab 6 today to get you all started, considering next week will be our midterm and we will not be doing much of lecture at all. So, all right. So let's start with working with views. So I think this was a topic I had come up with when we were talking about joins, and when you're working with multiple tables, the concept of joins can be used in the from clause to create views. So just give me a moment. I'm just looking for that part of the lecture, and I'll share that with you in a moment, please. Okay, so join views. This is a view generally created. First of all, what is a view? A view is a topic. View is something we create. So we use the create view clause to create a view, and view is an object. View is an object that is used to select data from multiple tables. Select, I mean, when we say actually select data, that means both rows and columns from multiple tables. So if I'm taking a query and trying to give it a name, trying to make it reusable, then I can make that a view. And so the fun part of working with views is that my select statements can become essentially very simple. So join view is a special kind of a view. Join view is more representation of working with multiple tables, working with n tables, using a join condition, working with n tables using a join condition, and then essentially creating this temporary table. So this creates a temporary table on top of which can be used for insert, update, and delete. So views are essentially created for convenience. So views are showing fields of the table that are based on a join. And in a join view, these can specifically be used for DML operations like insert, update, and delete. For a join view, it cannot have these things in it. Cannot use a distinct keyword, cannot use group by or having clause, cannot use aggregate functions, which are essentially group functions. Operations like union, intersect cannot be used. And clauses like start with and connect by cannot be, as neither we can use row num. So this is how a view is created. We say create view, view name, and as you can see, view EMP department becomes the label for this select statement. And because we are joining data from two tables, we've got a join condition, and we know what inner join or an outer join does. And because one of the columns in this view, employee number, is a unique column, because this column is a unique column, employee table is then the key preserved table in the view. So key preserved table basically means where we have the primary key and the values are the primary key values and row IDs will always be the same. That's the idea of the key preserved table, that the row ID, so key preserved table is the one, is a table in a view with primary keys. Used in the, that's the one that is used in the join. So key preserved table will have unique, will have primary key, which means that it's row ID and primary key value association is preserved. So in other words, if I'm looking for a specific value in a table, I can go get the row ID very quickly with the key preserved table. So essentially, the effect of key preserved table is that it can make finding information faster. It can make finding information faster. So once a join view is created, we can simply select from it like this. We can select from a join view like this. We can just treat it like a normal table and select values from it. So key preserved table, a few more review points on key preserved table. So in the example I cited, the key preserved table is the EMP table, and the keys are preserved in the EMP table, but not in the department table. I mean, department table also has the department number as the primary key. But the one column that I used first in the join becomes the key preserved table. And it is not important for the key column of the table to be in the select list. Like we don't have to select the employee number when creating the view. If that is the key preservation property that we are using, we don't have to use or put that in the select statement. Inserting values into a key preserved table is possible, but if we try and insert values in a non-key preserved table, then it may fail. So it really depends on if the constraints are, if there are some key constraints being violated. So for example, if I end up inserting the department number, this should be department number. If I try to insert department number for that does not exist, then that insert may fail. But if I'm only inserting values that are in, say, one table, like in the first insert, then it will succeed. When we have any constraint violations, when we do the insert, we can certainly have an alternative that is covered in the PL/SQL class, where instead of inserting the value, instead of inserting the value in the main table, I mean into the view, we can go and just do an insert in the underlying table. Okay. We cannot also insert values into the join view with the check option. Check option, what it does is it will check the underlying constraints to make sure that the values being inserted are not violating the underlying constraints, especially the primary key and the foreign key. So if the join view is created with check option like this, then the inserts cannot be done on that view. So deletes can be performed if there is only one key preserved table in the join view. So if we delete an employee, that's the child table, because department number is the foreign key. So we can delete from the join view if we are just trying to delete a row from the department, from the employee table, excuse me. And updates can be performed. But if check option is created, we cannot do updates. But if check option is not being used, then updates can be performed on the views. There are some data dictionary views available that allow us to check which columns are used in the views and which columns are updatable and which ones are not. So that is by simply querying the user updatable columns. And this is what the data dictionary looks like. So this was a topic that I think we had missed, or I had not talked about, or actually I had skipped. I wanted to come back to it and talk a little bit about what views are and how these can be used for updating data. Any questions on this topic? And if not, we will move on to the next item, which is formatting the output. So this is a part of this is something where you want to do good reporting using SQL. Then formatting data with SQL just is there are some good techniques covered in this slide deck. Some of you are interested in also in creating like a SQL file with code in it and doing test runs and so on. So today you'll get some information in that direction as well. So we'll talk both about formatting input and output, like how to get how to prompt a user for input in the SQL Plus environment, and how to produce readable output, and how to also create script files. So we can take these script files for writing outcomes from either queries or other things. So if we have the same query but different input each time, what we can do is prompt the user to enter value using single ampersand or double ampersand. We can also use the define and accept commands. And then once these variables or substitution variables are created, we can pass those into different SQL statements. We can also use substitution variables for varying or altering the headers and footers. So here is how substitution variables can be used. So we are using a single ampersand to prompt the user for a value right here. So what that does is it simply makes a prompt saying enter value for whatever column name we have provided, or whatever variable name we have provided. Once the value is entered into the into the variable, then that can be used for employee number. We can use set verify on. When we say set verify on, it will show the old value and the new value of the employee number. So this is the old and new that you can see in the bottom, and that's with set verify on. We can accept number or date or string with a single ampersand. If you are trying to read a character or date value, you have to put that in single quotes. That's the only difference between numbers and working with character and date values. We must put character and date in single quotes for the values to be read. So substitution variables can be used in where clause, order by clause, column expressions, table names, and also in the entire select statement. Here are some examples. So I can prompt column name to be entered. I can prompt for the where clause condition and the order by clause. Yet when I prompt for the condition, which is essentially a string, I'm not looking for single quotes because I'm going to use that value as is. Then we have the double ampersand. If we want to reuse the variable value, then we can use a double ampersand. If we want to reuse the value without prompting the user to enter it. So here we say column name, double ampersand, and then we use a single ampersand in order by. So in that case, what happens is I'll be prompted for value only once, but I'll use it twice. Once in the column select list and the other in order by. We can also define our own variables. Instead of using ampersand and double ampersand, if we wanted to get creative on specifying the type, creating a custom message for accepting or when reading values, then we can do both of those with define and accept. So an accept command will create a customized prompt when seeking the user input. So here you can see we have accept, then variable name. We can specify a data type that's optional, format. Prompt text is the custom prompt I was talking about, and then hide can be like if you're prompting a user to enter a password or something, you can actually hide that so the whatever user types is not visible. So here's how the different options of accept command will work. So in this particular case, we are saying accept. The name of the variable is department. Then the prompt is provide department name. And then we have our select statement, which simply says select star from department where department equals uppercase address of department, and that's the value for the substitution variable that we just created. Please notice that specifying the data type is optional. So specifying the data type of a substitution variable is optional. So if we want to create variables in our SQL Plus environment for reuse, perhaps across queries, then we can use accept. We can use the define and the undefined command. we can use the define and the undefined command for that. So the variable will continue to live in the session until the undefined command is used. And when the session is over, then the variables are essentially garbage collected or removed. But if you want those reusable, then we can put those in a file called login.sql that is launched every time when you log in, and then the variables that you need to use are always there. Now the way the define and the undefined command works is like this. We've got define department name equals a value, or we can just say define department name with no value. So this is used to declare. This part is used to just declare, and this part can be used to see what the properties of the variable would be, like if there is a default value that was added and so on. Then these variables can be used like any other, like the substitution variables that we created with either a single n% or multiple n%, like 2 n%. Both of these can be used, or this variable declaration created with define can be used that way as well. There is a set command that shows all the values. You can use the set command to essentially control values, environment variables in an active session. So like set echo on, set verify on, and so on. So echo on, when we use, it's going to pretty much reflect back every, or type back every property that it's going to reflect back every command I type on the keyboard. So if once I set echo on, if I use a select statement, it will then reflect that back. If we are using scripts of sorts, or when we start talking about scripts, turning set echo on is a good idea, because when you run your test output, then all the commands will be there before the output is shown. So these are all if you're trying to control the size of the line, the length of the page. So some of you were saying at the beginning of the quarter that there are only so many lines that show in a page. You can change that. You can set the page size to 100. So you can also alter the line size, because if you have lot of values or columns you're selecting, right? You can turn off the pause. So if let's say there is a pause every 10 rows or 5 rows based on the number of columns, you can turn off the pause, so you can see all the values properly formatted. So I'm sure you're going to enjoy working with this. You should try these set column commands a little bit to see how each one works, and then start applying them for lab 7 and 8, because I'll expect you all to create some useful scripts during that time, for especially lab 7 and 8 both. So all these customizations can be put in login.sql. Of course, we are on a shared system, so I'm not letting you all change I'm not letting you guys do a lot of these customizations. But if you have your own installation of the database, you will certainly be if you have your own installation, you can certainly modify it. Here is the formatting commands for columns, titles, and adding breaks. So the point is to try these out for different reports. So here is how the column command would work. That controls how the column is displayed. So you can take a column name and you can specify an alias for that column and options that are listed below. Like you can specify a format if the output should look a certain way. You can specify heading text or justifying it right or left or center. So all of that can be controlled using the column. So if I'm trying to show employee name in one line, not two, and I'm trying to use 15 characters for the column value, then I can do that. If I'm trying to use 7 digits for the salary column, I want to show a $sign in front of it. These are some things we can also do in values with the format function that we talked about earlier, a couple of weeks back. But we can also specify this in SQL Plus so the formatting can be done. Here is the if the value is null, then we can display no manager. So if you want to just see the settings that are created for a given column, then you can say column ename and it will display all the formatting criteria. And if you wanted to clear it, then you can say clear. So, and all the formatting elements are specified here, similar to the format function that we had talked about. So I'm not going to go through that since we have already talked about it. So if you want to suppress duplicates, we can use break command. And if we want to skip out rows, then we can specify the skip command. I don't think we'll end up using this for skipping rows or anything like that, but it's just nice to know. The title and the title commands for header and footer. So we can turn on the title, set a header, or set a header or a footer, or both. Running scripts in SQL, there's actually a way that we can do this. And especially for lab 7, you guys will probably end up doing this. So we'll start with set echo on. So each command I type is if you guys wanted to try this for lab 5 or one of the active labs you're working on, you can. So creating a script, I would save the file as, say, lab5.sql, and then we'll say we can add a comment with either two hyphens in SQL. We can add that as a comment. Then we say set echo on, which will repeat the commands, and then we'll also say spool that to a file. So I can say spool file1.txt, and then what that will do is, in the server side, it will create a file that will it'll create a file named file1.txt and start writing data to that file. After that, we will have some statements like select star from EMP, where where salary is less than 1,000. And then I can say set echo off. And I mean, if I'm trying to answer questions for each part in the lab, then I can add a comment, and I can say, answer to question 1 or answer 1. And then the last command can be spool off. So you can save this as a file, and then we can use WinSCP or WinSecureCopy to copy the file to the server and run the script. So let me see if I can show you all that quickly. So I have WinSecureCopy here, right? And I will need to talk to Voyager. Okay, so now I am connected to the server. So let me go ahead and create this little script first. So here is Notepad with the script, and I'll save it in my downloads folder for now. We'll call it test.sql. So the script is saved. So can you all see WinSCP here? Sorry, the font size is a little small, but I'm hopeful that it's visible to everybody. Yes? So we'll go to downloads folder, and there is my test.sql. And this is my home directory on the server. And all I'm going to do is copy this guy over. I can literally click and drag it, and it brought test.sql right there for me. So when I'm logged in my home directory, I have that. So I said I want to create file1.txt as my spool file. So one thing I want to make sure is, do I have a file called file1.txt already in this? And I list these in alphabetical order, and I do see there is one file called file1.txt. So let me go ahead and delete that, because I should use like a different file name. So now I'll log into Putty. think I've downloaded Putty, so one moment. So it looks like I'll need to download Putty. So I thought I had done that, but so there we go. There is Putty already installed, and I can open this, and so you all can see there is my Putty session. So, and now I'll launch SQL Plus. And it likes me, so so now I want to basically run that script that I created, and so the script that I created was, let's go look at WinSCP really quick, which I used for copying files, and it was called test.sql, right here, created this morning at 9:46. There is test.sql, and what test.sql is going to do is it's going to create, I mean, I can actually double click on this and read it. It's going to create a file called file1.txt when it's done. So I'm going to launch my script when I'm logged in by simply saying at test dot, I can actually just say at test and run it. So you can see what the output was. It said spool file1.txt answer 1, and then it executed the select statement. It shows all the results and then says set echo off, and then I think I also did a spool off in the file. So just to make sure I did do a spool off, let's open the file, and you can see the last line I did say spool off. That should basically close the file. So now if I go into WinSCP again, and I will need to refresh my my view here, and I should see file1.txt. So let me refresh, and there is file1.txt created at 9:51 this morning. Is that visible to everyone? Sorry guys, it's a little small, but if I open the file, you can see the output. So this is the entire process I use for creating a script and running it. I like to have WinSCP so I can drag and drop files between the server and and the client. And when I'm ready to run the script, I just put it in the home directory, and I simply use this command, the @ symbol, and then the name of the script, and then I'm done. So, any questions anybody has on running scripts? I think this is probably one of the more say useful skills that you all might go through, at least for the future labs. So especially lab 7 and lab 8. So everyone can still hear me okay, right? I haven't heard anything from anyone, so I just want to make sure. If people are still there. So, okay, very nice, guys. Thank you very much. So, running these scripts is was part of this chapter, just to kind of get you started and acquainted. So you can create the script, and you can either use start or do what I showed you, and then you can get a sample report. So, are there any questions anybody has on formatting or script creation that I should try and address at this time? So the next thing, I think for sake of time today, next thing I'd like to take on is, let's talk about the midterm first. And DML statements and transactions I'd like to leave for next time, but I'd like to spearhead conversation for lab 6. So so let's, that way, you all can continue working on lab 6 as you have time. So your midterm. So the midterm is scheduled for for the 21st. From 9 to 10:30. So it'll be Feb 21st, 9 a.m. to 10:30 a.m. You'll get 6 questions because the exam is an hour and a half. It will be online, open book and notes. And I encourage all of you to log into GoToMeeting to ask questions. You can, I mean, I can get on Piazza to answer questions and all, but I would prefer to answer them live, so I can be more quicker and responsive. So encourage you log into GoToMeeting to ask questions. And let's see, the chapters that I'll be covering, or the topics, will basically go through everything that was covered on until Feb 7th. So this stuff we are doing today, input, output stuff, transactions and all that won't be there. But all these other topics that were covered before the midterm, by Feb 7th would be there. So introduction to database features, knowing how the relational database theory works, some basics on Oracle architecture, And then a lot on the SQL statement, working with simple expressions, joins, all types of joins, SQL functions, group by functions, order by having, working with subqueries. So you can count on all topics till assignment 5. And for purposes of just completion of the notes, what I'll do is add that to your notes right there. So topics for the midterms are also added. So your midterm accounts for, I think, 25% or 30% of the total grade. So there is your grading. Final is 40%, labs are 30, and midterm is 30. So I think you guys like to, I guess, know that. If there are any questions on the midterm, I'm happy to address those. And any other questions? So yeah, please go ahead. Regarding your question on decode, please spell it out and I'll answer it for you. No problem. So the next thing we can look at is lab 6. Are there any questions for the midterm, folks? Sorry guys, I'm just waiting for, I paused because I'm reading up the question and responding to that. So you've basically got a question that says display grade of all employees based on the job column. That's it. That's good. So to debug this, what I'd like to have is the query itself. So one thing you can consider doing is emailing me the question and the solution you came up with, and I'll be happy to debug it and then send you back the results to answer this question. So you can see how basically decode works. Yeah. So are any questions about any other questions I can potentially help address? Folks in the room? Everybody good for now? Can we go over assignment 4, question 3? Certainly. So let me find assignment 4 quickly and then we will look at it. So here is assignment 4, question number 3. Write a query to display department names with salary grade, minimum sal and average commission. For departments with null commission, you should display 0. So I had suggested 2 ways of approaching this. So I'll cover one right now. So you show department name, and then we want minimum sal. So we take salary, and average commission. So since we want the minimum sal, right, we will first use group by function to determine the min sal and average commission for each department. So that's a simple group by and a join. So this requires a join between EMP and department table, and then applying a group by on sal column and commission column. So then based on, then the second thing we need to do is, once this is all done, we need a join between sal grade and the result created in part 1 that I just talked about. So I'll just add a side hint here that add part 1 in from clause. Add part one query in from clause. So you do a join between sal grade and the result from part 1 to do a join with sal grade table, and then you get your result. Does this help on the approach side? And then if you need a specific debugging on perhaps an answer you may have come up with, in that case, please follow up with an email, and I can help debug the code essentially. Is this helpful, or are there any follow-up questions that I can answer on this specific question? Okay. So next part is lab 6. So lab 6 is where we are actually going to do a bit of database schema design. So here's what a fictitious scenario is. That Dean of Admissions at De Anza College has hired you to do a database design for a new registration system. Keeping in mind the following requirements, design the DB schema. So we have college that has several departments, and then department has several courses, courses have sections, College has locations like room numbers and buildings, and then student register for a class. In fact, they register for a section from a catalog. And section basically means a course in a department with a timed entity with start time and end time and location. So, and then we have students have to take the course, they must pay the fees, and then their registration is updated. So what you have to do first is try and understand the basics of relational databases, what we covered in week 1. So in the first week we talked about the idea of primary key and foreign key. Does everyone remember that? To serve, to refresh your memory, I guess. So this is a slide from week 1 where we said that each table can have a primary key which represents a unique value. And then there can also be a foreign key. So like an employee table, department ID is the foreign key, so I can go and look up, I can go and look up detailed department information. So we create these links between different tables or we create these logical relationships basically between different tables so we don't have to duplicate information. So, now, while this is one foundational piece that we will need for lab 6, another one that we must go through is this guy, Introduction to RDBMS. So this Word document is something that we should cover in significant detail for you all to work on lab 6. And so what this is covering is some repetition from what we did on week 1, talking about the different types of databases. What is the relational database theory? So this talks about that every table is considered to be an entity in a database. It will have rows that represent the attributes. It will have columns that represents the attributes, and a row will be a single instance of all the attributes. So for example, if I have a student table or a student entity, their name, phone number, address, and gender. Let's say we are working with those 4 columns. then those 4 columns are the attributes. And if I populate information about one student in a row, then that represents a single instance of attribute values. In some cases, these attribute values may be missing. So for example, a person may not have provided their phone number or email address. Then the value in that row will end up being a null. We also say that there is at least one column that is uniquely identifying each row. So, and that's the row that we speak of as we speak of that one value as the primary key. So like in your case, a student ID uniquely identifies each student. So that becomes the primary key. But then we can also have a foreign key. We can have a foreign key, which basically means that we can have an attribute in one entity linked to another. So for example, if I was going to put your information for registration in a class, there's no point in me taking all the 15 properties in the student table and repeating those in the registration table. I can just take your student ID, make that a foreign key in the registration table, then I know which student has registered for which class. And I'm repeating this information, and it's kind of similar to the employee and the department table. So which department does the employee work in is pretty much set with representing department number as a foreign key in the employee table. So this is how entities can be related to each other. The order in which the rows are displayed or the properties are displayed is kind of arbitrary, because that's where the SQL statement plays a role in this two-dimensional structure. So after knowing these basics, time comes for using technical terms for representing these tables. So we can have fields. Fields are like employee name, employee ID, department number, and so on. Record is an entire row. Primary key is the one that uniquely identifies each row. And foreign key is the one that links us to another table. So for example, in this case, department number 300, states that Susan Miller works in department 300. So of course, we have been using SQL to try and access these tables. For Lab 6, it's important for us to understand the normalization theory. So normalization theory is, so we can minimize redundancies and inconsistent data. That's the primary goal of normalizing. So normalization theory is, in fact, it has 3 steps. It actually has 7 steps, but there are 3 steps that we use when we are creating a relational database to ensure that we don't have duplicity or inconsistent data or redundancies. So when we begin to follow normalization rules, we begin to say that a single piece of information is not duplicated anywhere. So we have these normal forms, first, second, and third. So there are actually like total of 7, but in this case we only apply 3 to get things off the ground. So they call it the first normal form, the second normal form, and the third normal form. First normal form says there should be no repeating fields. So if I, for example, have different types of products, I should not have column name product ID 1 and product ID 2 and so on. That would not be an optimal design. So if I'm trying to save, let's say a person has 3 addresses, then because they have 2 second homes or something, right? If I'm trying to save multiple addresses for a person, then I would not create repeating fields for an address in one record. What I'll actually do is create a separate table called address and link those with primary keys and foreign keys. I hope I'm making sense when I'm talking about the first normal form. So I wouldn't go ahead and create duplicate columns like address 1 and address 2 for a user. I would create a separate table and then link those with primary keys and foreign keys. All right? Then after the first normal form, we have the second normal form. So the second normal form is actually quite easy. It simply means that after you have no repeating fields, you want to make sure that the all the data that is added in a table, all the data that is added is dependent on the primary key. So you create one column in the table that is the unique value, that has a unique value. So usually an article table can have an article ID, an author table can have an author ID, and so on. Keep in mind, we are starting to now talk about creating DB schemas, something that we were just a consumer of in labs 1 through 5. Okay? So a unique key like an ID is always great, because then you can start to use these numbers to then or unique numbers can be used to link to other tables. If I have to apply the third normal form, I don't have repeating columns. I have given a unique ID. Then once those 2 rules or normal forms have been applied, I go to the third normal form. And it says that the keys must not be interdependent. Like you don't want a table to contain information that's already defined elsewhere. So a couple of examples of this would be that if I wanted to compute a raise in salary, like by 10%, I can just do a select statement with a simple mathematical expression. There is no reason for me to put that value inside the table in a column, because calculated column is not required. So that's one thing about the third normal form. The other thing about the third normal form is that if I'm already defining, say, an address of, if there's address information being defined in the address table, there is no reason for me to put that in the employee table. So that's why it's saying that for a table to qualify for the third normal form, it must apply the first two, and table, there should be no interdependency between columns in the same table or across tables. We are basically trying to avoid that. Before you start working on Lab 6, a clear understanding of these three normal forms is very important. And once you have those, then we can move on to the next step. So then the next step is designing the relational database. And that's where we, basically say that, well, let's collect requirement and then create a logical data model and then an entity relationship diagram. So first step is collecting requirements which are given to you. Then the second step would be to create a logical data model. And this is where we will represent the relationships between the different entities, create primary keys, foreign keys, and then there is actually a logic of representing those in either in an ER model, right? So we have all these things that we use for the entity relationship model. So the output of Lab 6 will have this kind of a diagram that you can either consider doing by hand or in PowerPoint. So here we see employee and department as an entity. And the hash, this little guy, represents a primary key. Star represents that it's required columns. O represents optional. So what we end up doing is creating these columns, and Then we also start defining the relationships in between. So what I'd like to do is ask you all to review this article called Introduction to RDBMS between now and 2 weeks from now when we meet again, which is February 28th. Okay? And what I'd like to do is spend an hour, about 30 minutes on 28th, 2 weeks from now, describing the 3 normal forms, how entity relationships are created, and how I want the chronotation diagram to be represented for lab 6. We'll cover those 3 things on 28th along with propelling forward with create table statement. And in between, please prepare for your midterm, take the exam, and you'll get the graded results pretty much within a couple of days, I would say, from the time you take the test. And then I'll see you back here on the 21st, a few minutes early from 9 o'clock, so you all can be prepared to take the exam. Okay? And you can start working on lab 6 if these concepts make sense, like intro to RDBMS, set concepts, and so on. If those all make sense, please definitely start. Otherwise, ask questions and I'll be there to definitely assist. Okay? So this is all for today. Everyone have a great rest of the day, and I'll see you all next Tuesday. Bye, everyone.